Going over the test, just doing a little HVAC study. For those who want to join and participate, that's fine. Figure I'd go live and help you guys out and help myself out at the same time, study together. And yeah, first question. You have a single phase compressor that will not start. You ohm out the compressor and read resistance between run and start, but infinite from common to run and common to start. The compressor is what? And answer is C. You have a three-phase compressor that will not start. The improper voltage at the compressor terminals. There's proper voltage at the compressor terminals. What can you do to try to get the compressor to start? You know what I'm gonna do? I'm gonna do it like this. I got a blank copy. So number 2. Number 1 is C. Number 2 is B. Reverse the 2 power leads. Number 3, you have a compressor run capacitor with a resistor across the 2 terminals. It bleeds voltage. To protect the service tech, that's A. To discharge the capacitor, B. To help the capacitor last longer, that's C. Or D, for off-cycle crankcase heat. If you know the answer, you can put it in, participate. The answer is D. You know that answer right there. Number 4, you have a single-phase compressor that draws high amperage and cuts out on eternal overload when starting. The most probable cause would be what? A, a bad capacitor. B, open windings. C, a dirty condenser coil. Or D, defective start relay. Number 4, the answer is D. (983) made man, I see your question. How do you reverse the power leads? Now, I'm studying just like you, but if I look at this thing, it says, which question was that? Reverse, which question was that? Let me see what question that was. It says a 3-phase compressor. Now, I work on mainly residential units, which are not, from my understanding, 3-phase compressors. Yeah, question number 2, I see it. Thanks for that. When I have a certain type of compressor that the 3-phase, I have another gentleman work on it. And I'm not exactly sure how that works, man, but I'll just say look it up. But I'm just going through the basic quiz just like you. I'm just studying out loud, and I'm learning just like yourself. So, but I don't work on 3 phases. The stuff I work on is mainly like single-phase compressors. So you have to look that up. But you can get this basic quiz online. It's actually free. But thanks for that question, though. All right, I'll go to number 5. But if you got any other questions, I mean, if I can answer them, I definitely answer it. I've been in the trade for about 14 years. And so I have an extensive knowledge on residential units, heat pumps, in single phase units, gas furnaces, and things of that nature. I don't too much do commercial. I don't too much do mini splits as well. I got contractor friends who actually do those for me. But thanks for the question. Number 5 is the ohm reading across a single phase compressor. And the reason why I can answer the questions is because I do have the answer key next to me. You don't see it, but I see it. So, okay, moving on. The ohm reading across a single phase compressor terminals are A to B equals 2 ohms, A to C equals 7 ohms, and B to C equals 5 ohms. So A is run, B is common, C is start. B is run, A is common, C is start. C is run, A is common, and B is start. Or D, A is run, C is common, B is start. Answer here is A. All right, number 6. In a split system heat pump, where would you find the accumulator? See, these are the kind of things that we work on here in Georgia. So in a split system heat pump, where would you find the accumulator? A, in the indoor unit. B, between the compressor and the four-way valve. C, in the suction line outside the unit. D, between the indoor and the outdoor units. Or E, in the liquid line leaving the condenser. I know the answer to that one, so that one is B, between the compressor and the four-way valve. Yep, 6 is B. Okay. Number 7, which describes the purpose of an accumulator? A, stores excess refrigerant. B, it acts as a muffler to make a compressor more quiet. C, protects the compressor from liquid refrigerant. Or D, keep oil from leaving the condenser unit. Number 7 is C, protects the compressor from liquid refrigerant. We don't want any liquid inside that compressor. You are working on an air-to-air split system heat pump. In the cooling mode, the compressor runs from the outdoor fan motor. Okay, I start over. You are working on an air-to-air split system heat pump. In the cooling mode, the compressor runs, but the outdoor fan motor does not. Further checks reveal there is nothing wrong with the fan motor or the capacitor. Which of the following is the most likely cause of the problem? A, a faulty heat relay. B, a faulty contactor. It says contractor, but it should be maybe contactor. Maybe it is a contractor, but. Or C, a faulty defrost control. D, a faulty reversing valve. 8, faulty defrost control. Number 9, an expansion valve heat pump system operates normally in a heating cycle but pumps itself down in the cooling cycle. Which of the following explanations is possible? A, the indoor check valve is stuck open. B, the indoor check valve is stuck closed. C, the power head thermal element on the outdoor expansion valve is faulty. Or D, the power head thermal element on the indoor expansion valve is faulty. Number 9, it's D. Number 10, in an operating air conditioning system, the normal flow of refrigerant leaving the metering device would next enter what? A, the evaporator coil. B, the condenser coil. C, the expansion valve. D, the compressor. Or E, the liquid service valve. Number 10, the answer is the evaporator coil. we'll stop at 20. Number 11. In a heat pump operating in the heating mode, if the indoor fan failed to operate while the thermostat was calling for heat, what would happen? Okay, I'm just seeing your other message, 983. You still there? What's up, Cool G's? I picked C on that answer, but I don't know the running start port location. If you wanted me to go back to that question, if that's the same one that we spoke about, let me know. If not, we can go back to it and check it out. But 11, let's see. In the heat pump operating in the heating mode, if the indoor fan failed to operate while the thermostat was calling for heat, what would happen? A, the outdoor coil will ice up. B, the indoor coil will ice up. C, the low pressure switch will open. Or D, the high pressure switch will open. Yeah, that's D. The high pressure switch will open. Number 12. In the heat pump defrost cycle, the following components operating is indicated. A, outdoor fan is off, reversing valve heating position, indoor fan on. Or B, outdoor fan off, reversing valve and cooling position, indoor fan off. C, the outdoor fan off, reversing valve cooling position, indoor fan on, auxiliary heat on. Or D, outdoor fan on, reversing valve and cooling position, indoor fan on, auxiliary heat on. Answer is C. Number 13. The cooling anticipated is what? A, in series with the thermostat contacts. B, in parallel with the compressor relay coil. C, in parallel with thermostat contacts. Or D, in series with the transformer secondary. 13, the answer is C. 14, the heating anticipated is what? A, in series with the thermostat contacts. Or B, in parallel with the gas valve coil. C, in parallel with the thermostat contacts. Or D, in series with the transformer secondary. 14 is A. 15. The heat anticipated is adjusted and set according to what? A, current amps through the 24 secondary. B, current amps through the thermostat. C, the VA rating of gas valve. Or D, VA rating of transformer secondary. 15 is B. Number 16, superheat can be adjusted by adding and removing refrigerant either on a fixed expansion device or a TXV system. Let me say that again. Superheat can be adjusted by adding and removing refrigerant either on a fixed expansion device or a TXV system. That answer is false. Maybe I'll do one more page before I call it a night. This is my first time doing this. I'm glad some guys take a moment to take a peek at this, studying out loud. We can study together. Number 17, which of the below best describes how to measure superheat? A, the temperature difference across a gas-fired heat exchanger. B, liquid pressure converted to temperature subtracted from actual temperature or liquid line. C, the temperature rise across condenser coil. Or D, suction pressure converted to temperature subtracted from the actual suction line temperature. 17, the answer is D. Number 18, what is the best procedure for measuring the oil pressure on a 7.5 ton coprometric compressor? Now, 7.5 tons will be something that I don't work on. And here in Georgia, we work on 5 tons. 5 tons or below. But the answer of the question is, what is the best procedure for measuring the oil pressure on a 7.5 ton coprometric compressor? I hope I'm saying that word correctly. A, the pump outlet pressure added to the crankcase pressure. B, pump inlet pressure added to head pressure. C, check with coprometric oil pressure gauge. D, pump outlet pressure minus crankcase pressure. Or E, if oil level is 3/4 up sight glass, pressure is okay. Now, I don't work on these, but I have the answer key. And number 18, the answer is D. Pump outlet pressure minus crankcase pressure. Number 19, what is the normal operating oil pressure of the above compressor? Is it A, 35 to 45 PSIG, B, 50 to 75 PSIG, C, 50 to 100 PSIG, or D, 5 to 25 PSIG? Answer is A. How you guys doing so far? Now, this should be an easy one. A compound gauge reads A, high pressure only, B, vacuum only, C, both pressure and vacuum, or D, pressure in a hot water boiler system. You should know the answer to this one, everybody. Number 20, the answer is both pressure and vacuum, C. 21, I think we'll end it here. You have a low pressure refrigeration coil. You have a low pressure refrigeration control with a cut-in pressure and a differential pressure setting. Cut-in is set at 34 PSIG. You want to cut it out at 22 PSIG. The differential should be set at what? A, 56 PSIG, B, 12 PSIG, C, 6 PSIG, or D, 24 PSIG. The answer to 21 is B. That's 12. I think we'll end it there. Thank you guys for tuning in. Just wanted to go live real quick. Something that I'm trying new. We can study together. Thanks for tuning in. This is Cool G with Cool G's Heating and Air in Atlanta. All right, guys. Y'all be safe out there. Peace.